Today we're embarking on a fascinating journey through the life of Sir Isaac Newton, a man whose discoveries have profoundly shaped our understanding of the universe. From his humble beginnings to his groundbreaking theories in physics and mathematics, Newton's story is one of curiosity, perseverance, and brilliance. Join me as we explore the key moments and contributions that define his remarkable legacy. Isaac Newton was born on January 4, 1643, in Woolsthorpe, England. His birth occurred just months after the death of his father, a farmer, who had passed away while Isaac's mother was pregnant. This loss deeply affected him throughout his life, as he never had the chance to know his father. When Newton was 3 years old, his mother remarried and moved away, leaving him in the care of his maternal grandmother. This early separation instilled in Newton a sense of independence, but it also left him feeling somewhat isolated. Growing up, Newton showed early signs of exceptional talent. He was an inquisitive child, often taking apart household items to see how they worked. His education began at a local school where he excelled in mathematics and science. In 1661, Newton enrolled at Trinity College, Cambridge, where he initially struggled to adjust to university life. However, his passion for learning eventually led him to immerse himself in the study of mathematics and natural philosophy. In 1665, the Great Plague forced Cambridge to close, sending students home. This turning point became a period of immense intellectual growth for Newton. Isolated in Woolsthorpe, he began to formulate his theories on calculus, optics, and the laws of motion, laying the groundwork for his future discoveries. This time, often referred to as his Annus Mirabilis, or Year of Wonders, would be pivotal in shaping his legacy. One of the most famous anecdotes about Newton involves an apple falling from a tree, leading to his thoughts on gravity. While it's unclear how much truth lies in this story, it symbolizes his ability to connect everyday observations with profound scientific principles. The story goes that while contemplating the nature of gravity, Newton saw an apple fall and began to wonder why it fell straight down rather than sideways or even upward. This moment of insight led him to formulate the law of universal gravitation. He proposed that every mass attracts every other mass with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. This groundbreaking idea fundamentally changed our understanding of the universe and provided a mathematical explanation for why planets orbit the sun and why objects fall to the ground. Newton's work on gravity culminated in the publication of his masterwork, Mathematical Principles of Natural Philosophy, often referred to simply as the Principia, in 1687. In this book, he outlined his 3 laws of motion, which further clarified the relationship between motion and force. First law, inertia. An object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. Second law, F equals ma. The force acting on an object is equal to the mass of that object multiplied by its acceleration. Third law, action-reaction. For every action, there is an equal and opposite reaction. These laws not only laid the foundation for classical mechanics, but also inspired countless scientists to explore the physical world with a new lens. In addition to his contributions to physics, Newton is credited with the development of calculus, a revolutionary branch of mathematics. His work in this field began around the same time as his reflections on gravity. Newton sought a way to describe changes and motion mathematically, leading him to develop the fundamental concepts of calculus independently, though contemporaneously, with German mathematician Gottfried Wilhelm Leibniz. Newton's approach to calculus was built on the idea of limits and instantaneous rates of change. He introduced the concept of derivatives, which measures how a quantity changes in relation to another. This concept is crucial in understanding motion, as it allows us to calculate velocity and acceleration at any given moment. Leibniz, working separately, developed his own notation and theories, leading to a bitter dispute between the two mathematicians over credit for the invention of calculus. Despite the rivalry, both contributions were essential, and their work laid the foundation for modern mathematics. Calculus has since become a vital tool in various fields, from physics to engineering to economics. Newton's contributions have allowed scientists to model complex systems and solve problems that were previously unsolvable. Newton's inquisitive nature extended beyond gravity and mathematics. He also made significant contributions to the field of optics. His interest in light began during his time at Cambridge, where he conducted a series of experiments with prisms. He discovered that when white light passes through a prism, it splits into a spectrum of colors. This revelation challenged the long-held belief that prisms colored light, and instead demonstrated that color is an inherent property of light itself. In 1672, Newton presented his findings to the Royal Society of London, earning acclaim for his work. He argued that light is made up of particles, which he called corpuscles. This particle theory of light would later be challenged by the wave theory, but Newton's experiments laid the groundwork for future studies in optics. In 1668, he also invented the reflecting telescope, which used a curved mirror to gather light instead of lenses. This invention was a significant advancement in astronomy, allowing for clearer images of distant celestial bodies. The reflecting telescope became a standard in astronomical observations and remains widely used today. In the later stages of his career, Newton transitioned from academia to public service. In 1696, he was appointed Warden of the Royal Mint, a position that would prove to be both challenging and rewarding. The English economy was plagued by counterfeiting, and Newton took decisive action to reform the currency and combat fraud. He implemented stringent measures to detect and punish counterfeiters, showcasing his commitment to integrity in financial matters. In 1700, Newton was promoted to Master of the Mint, where he continued his efforts to stabilize the currency. His work in this position was remarkably successful. He played a crucial role in the introduction of the gold standard, which provided a stable foundation for the British economy. Beyond his work at the Mint, Newton continued to explore his interests in alchemy and theology. He spent years studying ancient texts, seeking to uncover the secrets of the universe. His writings on these subjects, though less well known, reveal a mind that was not only scientifically curious, but also deeply philosophical. Newton's contributions to science were recognized in his lifetime. In 1705, he was knighted by Queen Anne, becoming Sir Isaac Newton. He had earned the respect of his peers and the admiration of the public, but he remained a somewhat reclusive figure, often preferring the company of books and experiments to social gatherings. Isaac Newton's legacy extends far beyond his own lifetime. His contributions laid the groundwork for modern science, influencing generations of thinkers. His laws of motion and gravitation became foundational principles in physics, and his mathematical innovations revolutionized the field of mathematics. Scientists like Albert Einstein built upon Newtonian principles to develop the theory of relativity, which further expanded our understanding of space and time. While Einstein's theories would eventually modify some of Newton's ideas, they did not diminish the foundational role Newton played in shaping the scientific method and inquiry. Newton's work also impacted philosophy, particularly during the Enlightenment. His emphasis on reason, observation, and empirical evidence shifted the way people understood the natural world. The transition from a mystical view of the universe to one grounded in rationality and science is often attributed to Newton's influence. In popular culture, Newton's story continues to inspire. His image is often used to symbolize genius and scientific achievement. From films to books, the narrative of a young boy contemplating an apple under a tree has become a powerful metaphor for curiosity and discovery. In conclusion, the life and legacy of Sir Isaac Newton are a testament to the power of curiosity and perseverance. From his early struggles to his groundbreaking discoveries, Newton's contributions have fundamentally shaped our understanding of the universe. His laws of motion, theories of gravity, and innovations in mathematics have paved the way for modern science and continue to inspire future generations.